Well, good morning, good afternoon, good evening to everyone, wherever you may be across the world. Thanks for joining us live today, again, for Serverless Office Hours, streaming on AWS and also on Serverless Land. I'm Julia Wood, a Senior Developer Advocate for Serverless at AWS, and this week is Messaging and Events Week. And I'm super glad to be joined by my colleague, James. James Bezic, how on earth are you?
Hi there, everyone. How are you doing? Nice to be here again, Julian, with you. How are things?
Thank you very much. Yeah. Very good. It's already May, which seems bizarre and strange, but the year is going on. How are things in your part of the world?
About the same, yeah. It's December 76th right now, I think, yeah.
Yeah, I still think we're going on. It's March 2020, but how many, 80 trillionth week of March 2020. It still feels like it.
It does, yeah.
Cool. Well, yeah, thanks so much for joining us here today. If my slide is going, I should have put that up first. That would be a much better host. So those are our contact details. Please feel free to get in contact with us via Twitter. And of course, today is all about James giving some information, but also very importantly about your questions. So please send any questions you have within the chat functionality with whichever channel you are broadcasting them on, or watching our broadcast. And yep, we'd love to be able to answer your questions if we can. So just to recap from last week it was Amazon API Gateway, and we had Ankita Yadev, who's one of the product managers on the API Gateway team, and she did a really excellent session on IAM condition keys and really went through from sort of read-only access all the way up to some of the more interesting use cases you can do. So go to the Serverless Land YouTube channel, and the recording is available over there. Thank you, Ankita Yadav and Eric Johnson, for hosting that. Yeah, that was a great presentation. Now, also, what's new in AWS Serverless over the past week? Not just over the past week, but a really cool feature is from Amazon CloudFront, Amazon CloudFront Functions, and this is really a lightweight edge compute capability, and this is not even within the edge regions, which is where Lambda at Edge actually runs, but this is within the CloudFront POPs. It supports Node.js and for very small little functions and sort of header manipulations and things like that you maybe want to do at the edge. So that could be super useful for you. Amazon SNS has grown the set of message filtering operators. This just allows you more information, more flexibility when you are sending your SNS messages to separate targets. Not quite serverless related, but of course lots of serverless people are using RDS, and I just spotted this, that the SQL Server supports managed disaster recovery with cross-region automated backups. So RDS setting it up is fine, but you've also always got to manage your disaster recovery and your failover kind of things, and this just makes it easier for you for that persistent state which you're going to be doing. CloudWatch Synthetics supports some cron expressions for scheduling. So if you're doing cron stuff, particularly when you are testing your Lambda applications, you can do this on a schedule. IAM has come out and also made it easier to manage permissions for your AWS services for accessing your resources. And there are some new condition keys that IAM have got, which may be useful for you. And just lastly out is Amazon VPC announces a pricing change with VPC peering. And this means, if I just remember, because I was silly and didn't do my note, but I think it's a VPC peering within the same availability zone is now free. If you do VPC peerings across availability zones, you do pay, but VPC peering within the same availability zone is now free. Less money always makes everybody happy. Recapping some of the compute blog posts over the last week, the amazing, excellent performance optimization Lambda operators guide by none other than James Bezic is performance optimization part 3. So yeah, that's a really super long guide with just so much useful information. It's just worth really reading that, not only if you're building serverless applications from scratch, but looking back over what you've already built and adding some operational insights from James, which is excellent. New person on our team, Talia Nasi, has done an amazing job, and she's talking about the serverless patterns collection, which I'll jump to a slide a little bit later. But this is literally how you can integrate services using infrastructure as code. Talia, congratulations, you got your first blog out on the AWS Compute blog. Woo! And it's an excellent one. So good to have you an even more, even more accomplished / delivering person on the team. So that is awesome. Ben Smith is doing his Getting Started with Serverless for Developers guide. He's on to part 3, talking about the front door and API gateway. Ben's also done something with Data Flow Simulator, which is a cool modeler for step functions, which we covered 2 weeks ago in the show, so you can have a look. Jumping around again, AWS SAM and the AWS CDK now work even better together. You can deploy CDK applications using SAM. Yeah, it's not an either or anymore with Eric. And then also Dario Laporta using shared memory for low latency intranode communications in AWS Batch. So that's looking over some of the past week and a bit on the serverless blogs. As I mentioned, James's Lambda Operators Guide, lots of information over here. This is, use the QR code to get into that. It's right in the documentation, and plus there's a whole bunch of the blog posts James has written to go on to that. Anything else to add, James, that I've butchered your Lambda Operators Guide? What else do you have to say?
I think that's a pretty good summary, Julian.
Cool, sold. Thank you very much. Then I mentioned with Talia's blog post, this is the serverless patterns collection, s12d.com. S12d is our URL shortener for our serverless team. And these are the serverless patterns. So if you want to wire up API gateway with Lambda, or you want to wire up Lambda with step functions or some kind of thing, these are literally copy and paste snippets of code, either via SAM or via the CDK, which you can use in your serverless applications. And they're more and more being added all the time. How many are we up to now, James? I'm saying 34.
I think we're up to 40.
That's my
or
guess
somewhere
of the
around
day.
there, yeah.
Oh, there we go. You snooze, you lose. I'm behind. So yeah, and we're going to be adding even more. These are open source as well. So if you have any talking specifically between 2 single services, so you've got some ideas, we'd love to hear them from you. This is Ben Smith's Getting Started with Serverless Guide. I'm actually all doing mentioning the blog post and then getting onto the slides and getting it all back to front. But anyway, if you're new into serverless development, this is a really getting started guide from the beginning. It doesn't assume you know anything. It's a really good way to just understand what serverless is about, you know, without all these funny terms that get bandied about. So James is Ben is doing a great job helping you get started with AWS services. Serverless. Next week, up on May the 19th, there is Serverless Live, and this is joining serverless subject matter experts, which James and I can count ourselves in that cohort. So it's a virtual day, deep dives, demos, and more. Register now. It's obviously free to use, free to view. There's Adrian Cockcroft starting the day off, Jeff Barr finishing the day off, and we got the whole serverless developer advocacy team. I am doing a talk on AWS Lambda extensions. James, I believe in you doing what we're talking about today, correct? Is there another one as well?
Yes, I'm talking about streaming today and next week. Lots of streaming.
Brilliant. Well, and then there's doing APIs, and there's a whole bunch of talks. So head over to the QR code over there. And yeah, that's going to be a great day from some really good, deep technical content. So as I mentioned, this week is AWS messaging and events, and over to Mr. James Bezic for Kinesis or the streams.
Great. So today I was going to cover a few different topics because, you know, streaming data is basically complex, and however you do it, it's actually fairly tricky to do on a workload basis. And so taking a serverless approach can actually take a lot of the heavy lifting out of dealing with streaming data, but it is a hard topic. And so what I did is I put together some of the common things we talk about with Kinesis and with streaming with Lambda, and just put them all into a deck, but I'm happy to take any questions that anybody has. So I was going to first talk about some of the streaming use cases, because often it's not obvious why people build streaming workloads. So if you think about how things are regularly built in many companies, you have this batch processing approach where you might have hourly server logs or weekly or monthly bills or daily reports. And what managing streaming data does, it allows you to move into a real-time or near real-time mode where you can create real-time metrics or real-time fraud detection in the case of financial institutions who use this. And so really the whole opportunity with real-time opens up when you bring streaming into the equation. And so there are a few different common uses that we see customers using streaming data for. Some of the most common ones are log analytics, going through logs of systems. Video processing is increasingly something that's more and more important, but also things people don't think about. You know, for data lakes, it's a great way to get data into data lakes. Or if you're working with IoT devices or industrial automation, and you've got different devices emitting data all the time, then streaming data workloads can help you get data from those devices into the cloud, where you can then process it and turn it into insights from real-time dashboards and that kind of thing. So another thing that comes up very frequently is that Kinesis is really 4 products under the umbrella of Kinesis. And so these are the 4 ones. I was just going to try and explain the difference in a sort of easy to capture way, because you've got Kinesis Video Streams, which is, fairly self-explanatory. If you're working with video, that's the one you want to be using. There's Kinesis Data Analytics, which is something that's like thinking about a real-time SQL processing database. If you imagine your stream is a real-time flow of data, you can run SQL-like statements using analytics. And then the 2 other products that are frequently confused. You've got Kinesis Data Streams, which is the basic product where if you want to put data into a stream and then reprocess it on the other end, that's probably what you need to use. But then there's Firehose, which is a whole separate thing by itself. So if you need to load that data into an endpoint like S3 or Redshift, then Firehose is a really good choice because it's completely serverless. There's no administration or anything you have to do. So anytime you need to actually take a stream and then transform that data and put it somewhere, most likely Firehose would be the right choice for that.
James, a question I also hear from some people or think about them is, okay, we've got streams and we've got events and we've got notifications and all these kind of things. How would you maybe differentiate between maybe just streams and events?
Yeah, it's a very good question. I mean, I think although they're conceptually fairly similar, when you get into the weeds of these things, they're actually fairly different. So, streaming data workloads, what characterizes them more than anything is just a massive amount of constant data that's coming from often thousands of different places. And it's raw data just coming at you. And the goal of using something like Kinesis is to basically operationalize the idea of collecting all that data, putting in a queue so then you can do something with it, because that by itself is a massive task. When you think about event processing, typically you're dealing with structured data coming from services, AWS services, your own applications, where they're emitting pieces of information that then you want to filter on and route somewhere. And so there's actually more structure to an event typically than there would be from a raw stream. But and typically event-based systems don't generate this much data, but that's actually changing too. A lot of event-based systems now increasingly are creating quite a lot of data.
So I suppose that's the reason for having, because a stream is, the producer's actually doing very little. It's just dumping raw data extremely fast on a stream. If you're thinking, an IoT device or something like that, and that hasn't got a whole lot of processing power, it hasn't got a way to maybe aggregate or do some kind of stuff. So a data stream is just, a lot of raw data that then the consumer of that data then needs to analyze, parse, filter, and do all of that. While an event-based system, you're assuming, I suppose, that the producer has a little bit more smarts, that it can add some metadata, it can structure something, and that producer would then need a little bit more, processing power to be able to do that. So just different ways and different doing. One day in the future, maybe we'll converge on on similar ways to do this kind of thing. But yeah, the laws of physics also sometimes against us with the huge amounts of data that flow through these various things.
Yeah, absolutely. And also, it's oftentimes with events, the service that's emitting events isn't necessarily sending them to anybody either. So you may be a notification that's going out into a bus, and it's not really directed at anybody in particular. Maybe there's nobody listening to that event. Whereas typically with streaming data, the sender of the data is expecting it to be caught and processed by something. So there's a few semantic differences between the two. But generally speaking, when you look at streaming data, this is the sort of pattern that you see. You've got this producer, the data producer, who continuously produces data. And that's also one of the things about streaming data is what is streaming data versus regular data? Well, typically it doesn't really end. It doesn't have a clear delineation of when it starts or ends. It just goes and you keep getting it. So if you imagine, your car emitting events or your refrigerator, or fitness devices, they're typically sending out data, from your Fitbit constantly, and there's no expected end in sight. And then once you get to the middle part, you've got some sort of streaming service in the middle that's capturing all this data, storing it durably, and also providing a temporary buffer. And in some cases also ordering, like Kinesis does as well. And these systems are capable of handling massively high throughput. I mean, they do an amazing amount of work to be able to handle gigabytes of incoming data constantly. And on the side that we care most about, because we can impact it the most as developers, is the consumption side. You know, we can write applications that continuously listen to these streams and process this data, and then transform it into things that can help provide insights into what is going on within the data flow itself. And so when you look at, if you look at the Kinesis realm, I mean, a record is really pretty straightforward. It just contains these pieces of information. You have a partition key, which I'll talk about a little bit more in a minute. And then you've got a sequence number that's provided by the service when it receives the record. And then you've got this data, which is a base 64 encoded blob. And your data can be up to 1 megabyte in size per record. And so all these producers are basically producing these JSON pieces that look like this and sending them into the Kinesis service. Now, what's interesting about streams, and this is where people get a little bit confused, is that streams are really just a collection of shards. And so you can think of shards as being like mini streams within the stream, and they have fixed capacity. So you often see the pipe analogy used here, because one shard can handle up to 1,000 records per second or 1 megabyte per second. And so you basically, when your pipeline or your one shard fills up, you add more shards so that you can start spreading the amount of data coming into this. And so the stream is really this conceptual grouping of shards. There's really nothing more to it than that, except that the shard management is something that you have to think about as well. I was just going to stop and see if we have any questions, by the way, because I know that we've my screen has gone.
No, fair enough. We don't have quite a question, but we do have a comment from our erstwhile colleague who's obviously missing the stream desperately. So Eric's saying, with streaming, you can analyze data as it arrives rather than just waiting for all of it. So yeah, James alluded to that, but yeah, that's 100%. You're not waiting for a whole huge object to be uploaded to S3 or a file to be put somewhere. Yeah, this is small continuous bits. Yeah,
and actually the throughput and the round time, the round throughput time of this is very, very short. So if you build these sorts of systems with Kinesis and you use enhanced fan out and you have very well optimized functions, you can go basically from your producer to your consumer very, very quickly. Typically you can see like under 100 milliseconds. So you can build things to be very close to real time.
And Eric, oh, wrong one. Eric, yes, we miss you too.
We miss you, Eric.
We do have a question with Code Sean. As you can process data as it comes in, does it mean that I can use Lambda to process it in flight?
It does,
well.
Absolutely. But I'll show you that in a minute, because there's a bit of subtlety to it, whether you use Kinesis Data Firehose or Data Streams. But absolutely you can. It's one of the most powerful reasons to use Lambda. But just very quickly on this, just not to beat it to death on shards, but the throughput's really important when you think about shards, because that's one of the things you have to manage when you're using Kinesis. And so when you see that your incoming records are starting to get close to this throughput, you need to take action to scale up your shards. But otherwise, the shard itself is self-managing. The data comes in and it queues up in the service, but you do need to watch the capacity. So that's why I put this slide up here. Now, right on cue, we're talking about Lambda. So, of course, Lambda is our on-demand compute service at the heart of the AWS serverless portfolio. And so the Lambda service polls the Kinesis shards automatically for you. And this is one of the key things here that makes it very powerful. So Kinesis delivers the records that are coming through the stream as a payload to Lambda. And then the same Lambda configurations apply that you're used to, in terms of you can use any runtime that you prefer. You can do pretty much whatever you like in that Lambda function in terms of integrating with other services, looking up other information. And really, there's just some configuration options to decide how many records you want to receive in each batch, how long you want to wait for a batch, and also where you want to start in the stream. So there's this concept of starting at the latest, which is the latest record that arrived, the trim horizon, which is the earliest record that's available, or you can do it based upon a timestamp. But in terms of once you've set up that configuration, the Lambda function itself works really very similarly to how you're used to seeing Lambda before. So if you think about this polling process, so for every shard, you've got Lambda will then configure a poller that polls the shard every second, and it will invoke your Lambda function when those records become available. And this poller is managed completely internally by the Lambda service. It's not something you see. So if you look at the record processor here, this is what polls the Kinesis shard, and then the batcher then creates the batches that then get processed by the function, and then the invoker then gets those batches and invokes your Lambda function. So that's really what happens under the covers.
But yeah, you don't have to worry about that. You're not having to scale up or manage producer, the record processors, batches, or invoker. This is just the polar that sits within the Lambda service that does all this on your behalf, and ultimately grabs data from the stream, sends it to your Lambda function.
Yeah. I mean, it's actually a very, very simple integration in many respects. I mean, I think the Kinesis plus Lambda combination is really a hand-in-glove fit, because when you think about the challenges of processing streaming data when you don't do it this way, and I've worked on workloads where we were using, instance-based approaches to this, it's actually phenomenally hard to manage and control. Whereas if you use the Lambda-based approach, it follows the same paradigm. You're essentially just receiving batches of events. You build your custom logic to process those events, and it's a stateless idea. Essentially, if you can build a Lambda function that can successfully process one event, there's no reason why it can't process millions of events. And so I think it's actually a very powerful model. Now, one of the things I really wanted to just talk to everybody about quickly is Kinesis Data Firehose, because I just think this is an amazing service and what it can do. So, this is totally serverless. If you want to think about the best part of Kinesis being serverless, this is the service. It's fully managed completely. It automatically provisions and manages and scales all the resources that it needs to do to process the workload. And it really only takes about a minute to set up as well. So this is the diagram from the main site, but what it's really showing here is that you've got the same sort of input on the left where you're receiving lots of events. But the big difference here is on the right-hand side, you'll see that we have some sort of data store involved. And this is typically the most common use case where you're loading data into S3 or Redshift or Elasticsearch or something like that. You can actually send it to other partners like Splunk, and it does support HTTP endpoints as well. But most commonly, I see this being used with S3. And this is amazingly powerful because you can send gigabytes of information to Kinesis configured with Firehose and just watch the aggregated objects arriving in S3 buckets. And you literally don't have to do anything to make that happen. So there are just a couple of important things when you set this up that are worth thinking about. So you've got this the source where it comes from. That can be an existing data source, data stream from Kinesis. It can also be things like CloudWatch events, CloudWatch logs or EventBridge. And actually, a really overlooked one is AWS IoT. So if you have an IoT device in your workload and you're collecting streaming data, you can go straight from your device through IoT Core to Kinesis Data Firehose. And so from the development point of view, you just watch your payloads arrive, and how they get from the device themselves is fundamentally managed for you. And then the only other thing here that's interesting is the buffering aspect. So, one of the big differences between this and data streams is the fact that there is an element of buffering going on. So you select a time between 1 and 15 minutes. That's how long the service will wait before it writes the output to the destination service. And you also set a volume, which can be between 1 megabyte and 128 megabytes. Whichever one of those is reached first, it then triggers the delivery of the records to the destination. So the question from earlier about Lambda is really interesting here because you can actually integrate Lambda into this flow. And so if we look at this, what you've got here is the same as the previous slide, but in pictures. We've got records arriving from the data source. They're being delivered as transformed records to the service on the right. But you now have a Lambda function up there, which is performing the data transformation function. And so essentially, this is then the service invokes the Lambda function with batches of records and allows you to do things like manipulate those records or even drop records entirely if they're records you don't want to continue on processing downstream. And then you return an object back to the service, and that's as simple as it gets, really. There's a couple of other things just are interesting about this, that any type of failure can be saved also to an S3 bucket. So it's one way of just keeping track of anything that's not working out properly in your workload. But also you can deliver all the source records as well. So if you want a place just to capture the raw data, you can configure that to go to an S3 bucket as well. So let me just stop to see if there's any questions quickly before I get into this Lambda part. It's exciting.
Yeah, certainly. Well, and we did have a question about what are some good shard scaling practices at the moment?
Yeah, I get into that a little bit later in this, but shard scaling largely comes down to monitoring your capacity within the shards, and then using the tools to be able to reshard automatically. That tends to be the best approach in many workloads. But you can use CloudWatch to set alarms to make sure you're monitoring the state of how much capacity you have in Kinesis streams. But the other side of that is also thinking about your partition key strategy, which I'll talk about in a little bit more. To give you a preview of this, you've got a couple of options. You can essentially pick something random like a timestamp or pseudo random, where that essentially will put records into the stream and they'll be distributed over any available shards. Or you can do things where if you want to group by shard, if you've got a fairly even balance of data across different group IDs, you can use the partition key to form a grouping by shard, but that really depends on what sort of workload that you're implementing.
Thanks. And Struthmate, Australia must be.
Yay!
The Lambda shard iterative tracking iterator tracking feature is the best feature. So yeah, thank you for that.
Yeah.
And then just another question about, is there, sorry, I'm jumping between questions. Carry on, James.
Yeah, actually, it's a really good point that Struthmate makes there, because one of the difficulties with managing streaming data is actually tracking where you are. So if you think about having multiple consumers off a stream, this isn't like SQS where they're all receiving separate batches. They're actually receiving duplicates of the same records, but they're in different places in the stream. So the service manages exactly where they are in that stream for you. And if one of your consumers has a problem and starts to slow down or throws errors, it's still maintaining the tracking of where the other consumers are. So this is something that really is pretty straightforward in Kinesis in terms of implementation, but tends to be fairly difficult to do if you take other approaches.
Thanks. And from the tech guy, is there a Kafka-like consumer grouping to scale concept?
It's not really the same, because we've got this topic idea in Kafka, and in Kinesis it's really based around shards, but they're not really similar. I mean, I've seen people use the partition key idea, like topics, but it's not quite as balanced. You can accidentally overheat shards if you do that. But so it's not directly comparable, no.
Okay, thanks. Yeah. Any other questions? Keep them coming.
Yeah, keep them coming.
We'll do our best to answer. Well, I'll say James will do his best to answer. If not, we can send them on to more expert people. But yeah.
Yeah, it's a tricky conversation. So I invite all questions about streaming, because definitely it's one of the more complicated topics. But yeah, so if you look at this data transformation piece, this is what's interesting, that you can essentially pass data in to your Lambda function. It arrives looking like this. So you get this JSON delivery with record IDs, and you've got this encoded data payload as well. Your Lambda function does its work on this payload and then returns an expected structure that has to conform up to this sort of structure, where you include the same record ID as you received. You have one of three results. You're allowed OK, dropped, or processing failed. And then you can return back the encoded data with any changes that you've made within the function. And so the most important thing here is you have to recognize that you've got to return this value back to Kinesis Firehose. And if you don't do that, you'll get errors, because it's expecting that. So you've got up to 5 minutes to perform a data transformation in the Lambda function, not 15 minutes as is the usual. And so if you think about some of the things you can do here, these functions are really commonly used to filter and enrich and convert data. And so you could do things like a geo IP lookup. If you're pulling an IP address from an incoming stream, you could use a service to go and look up where that is, then put the location back into the data payload. And so really you have complete flexibility in modifying the payload in any way you want, and doing pretty much whatever you like within the Lambda function, providing you sit within that 5-minute time frame.
James, I've got to pick out that your source IP is 127.0.0.1, and it's retrieving from your geo IP to Boston in Massachusetts. So that must be home.
Yeah, I'm not sure how that happened. Yeah, so you've got Firehose then can invoke these data transformation Lambda functions, but it also does scale up as it needs to. So, this is another great part of this service, that under the covers, Firehose is essentially scaling up, and you have these massive amounts of data coming in. It's also scaling up the Lambda function as well to keep up with the traffic. And so you're allowed up to 5 outstanding Lambda invocations per shard. And if you're using Splunk, that quota is 10. But just bear in mind that's something that happens. So when you're writing your Lambda functions, you want to keep these stateless and just assume that every packet of data is brand new and you know nothing about what happened before. And then I'll just talk about some monitoring of Firehose, because this is something that it really is a fundamental part of streaming applications. I would say more so than other types of applications. So if you've ever worked with streaming workloads before, you'll know that when things go wrong and they back up very quickly. And so if you're on top of your monitoring and you've got a good strategy for monitoring a streaming workload, that's really a big part of your maintenance challenge solved. So the good news is that Firehose completely integrates with CloudWatch. So you've got some CloudWatch metrics that you can monitor to keep on top of a lot of these things. You want to look at the execute process.success metric for the delivery stream and make sure this is as close to 100% as possible. And if it's not, then you want to find out what the failures are that are causing that. And also you want to just look at the delivery to star.success metric, which should also be with 100%. So there's not a huge amount to monitor with Firehose, but if you keep a couple of eyes on those metrics, that should pretty much keep you in good standing with your Firehose workload.
But James, also Firehose does keep the data within the stream for a while, doesn't it? So
yes.
You do have time to investigate. It's not as though it's a stream that's you've got whatever seconds to do something or it's lost. You can keep this data in the stream for a while.
Yes, and so it doesn't operate in quite the same way as Kinesis Data Streams, but you do have some flexibility. Yeah, in Kinesis Data Streams, you also have replay capability as well. So, by default, the records are held for 7 days, and you can go back and replay from a given point. So it's got this sort of videotape capability where you can go back and replay, which is incredibly useful if you're trying to work out, if you want to test code, for example, on live sets of records that are coming through. It's a really useful feature. And that takes us on to Kinesis Data Streams. Before I jump onto that, I'll just see if we've got any questions leaping out of this.
Yeah, we do have a question which is worth talking about costing. Are Kinesis streams costly as soon as they are stood up, or is it on a use basis such as Lambda and DynamoDB? And just before you do jump onto the costing thing, there is sort of a debate, how serverless is Kinesis, because you do have to manage those shards, and you do have to scale them up and have to scale them down. Kinesis doesn't quite scale to 0, but yeah, lots of different people talking about whether it is or isn't. Kinesis takes a lot of that undifferentiated heavy lifting off your shoulders, so we'll err on the side of it's more serverless than it's not. But yeah, how does the pricing work?
Yes, the pricing with Kinesis, with Kinesis Data Streams, works on the basis of how many shards you have, and also there's a data transfer charge based upon puts. So there is an ongoing minimum cost, even if you set one stream with one shard. It's fairly minimal, though. It's not nowhere near the cost of if you try to build this sort of solution yourself. Whereas Kinesis Data Firehose is based upon usage. So if you have nothing coming into your Firehose, it's not going to cost you anything. So it depends which product you use. Now, one question here I see about how to send data.
Thanks. Yeah, and we've just got some comments as well to add to that from. Yeah, let's put that one up.
Sorry, there's a slight lag. Yeah, so how do you send data from on-prem to Kinesis? So
yeah, me too.
We got a lag. So how do you send data from on-prem to Kinesis? So it depends on your workload. So if you've got an IoT workload, you could do something like the IoT core publish events process, then connect your IoT thing using a rule to your Kinesis stream. That's an option. You can use the AWS SDK as well to put data into your stream. There's also the Kinesis client library that's available depending on what you're using. But one of the most common ones we see is people using the SDK, because you have a choice of putting events in the stream either one at a time, or there's a batch option to put up to 500 records at a time. Okay, so I'll talk about Kinesis Data Streams a little bit. So this is a massively scalable and real-time data streaming service. And so when you look at Kinesis Data Streams, this is typically how this would work with Lambda. And so you have Kinesis makes sure streaming data available to multiple real-time analytics applications, for example, within a couple of seconds of the data being collected. And you can have up to 5 Lambda consumers per stream. And if you're using anything like Kinesis Data Analytics or Firehose, those do count the subscribers. It's something you have to remember. But in this case, the Lambda service polls the shard every second for new records and then passes those on into your Lambda functions in serial, one after the other. So in this case, we go through the details of what it looks like. You've got a Lambda service that's polling the shard every second for the set of records. It then invokes the Lambda function synchronously with that batch of records. And if your processing is successful, it just moves on to the next batch. But if it's not, then we get into the retry and failure behavior that really depends on what you want to do and how you've configured your event source. So by default, what happens is that Lambda will simply invoke the function again with the same batch of records, and it will continue to do this until the batch is successful or the records expire out of the stream. So there's something really important to keep in mind, because if you have a failure that just keeps happening, it will just keep retrying without in the default settings. And so this isn't often what you want, and so there's depending on what's gone wrong, it depends on how you might want to set this up. Typically in a processing failure, often it comes down to a single record that isn't formatted correctly or there's some sort of problem. And so there's the bisect batch on function error feature, which is actually a really good way to try to handle this. And what it does is Lambda then splits that batch into 2. It retries the oldest half of the records first, and it keeps splitting recursively until it finds the batch of 1 that is the problem. And so it's kind of a clever way of finding a record quickly. If you've got batches of 1,000 records within a few different splits, it can actually find the problem record relatively fast. And then the only other thing to think about are the maximum number of retries and age, because this is something where Lambda will retry a batch until one or the other of those is met. And so it depends on the needs of your workload as to exactly how you'd want to configure that. I think I've lost Julian, but I will keep going and see if we've got any questions for a couple of seconds.
Yeah, funny internet happening probably by me. So just this was talking about the on-prem. So yeah, using some kind of proxy or some other kind of thing. Thank you from Thomas. There was also just talking about, I think James may go on to that, about shards being priced per hour. That was based on the pricing. So why is Bob not allowed? Thank you for that. There was another question from, so add on a proxy service skills have an API gateway HTTP input that uses API gateway's capabilities to call to AWS services like Kinesis directly. I suppose that's a possibility. I'm just thinking the throughput for API gateway isn't going to be as much as Kinesis, or interesting.
Well, I think some people do this actually, but one of the reasons not to is simply that if you're invoking API gateway at that sort of scale, you might be spending more money than you need to. So it depends on what you're invoking from, because if you can avoid the extra cost, then why not? You can find alternatives. Having said that, if there's features that you really need an API gateway, then it's a fine solution. There's nothing stopping you from connecting the two, because API gateway will scale up pretty aggressively as well.
Yeah, no, Thomas, certainly. If you do have a good use case, please get in touch either with us or even with your TAM or support reps, and we'll be happy to raise that with you, with the support team. It's also, API Gateway has a lot of functionality. If you are sending things to Kinesis directly, maybe you're not going to need the whole functionality of API Gateway, which is partly my long-winded answer of saying also look at things like ALBs or things like that, because that has very high throughput and can potentially be lower cost if you don't need throttling or rate limiting or all the kind of advanced functionality that API Gateway has.
I saw a question here about SNS to S3, by the way. And I don't know the exact issue that the next TV is describing, but I would recommend using SQS instead. So if you've got S3 to SQS to Lambda, if you get a large number of objects uploaded, that queues up the requests in SQS. Now, if you're finding that SNS is invoking you multiple times, that would indicate to me that the Lambda function is calling is throwing an error of some type, and that's making SNS retry. But I'd definitely check for errors, and I'd consider looking at SQS as an alternative. Let's see. So yeah, talk about the volumes on Kinesis and API Gateway. No, the Kinesis is not too high for API Gateway, but one thing to bear in mind is your default limits on API Gateway are usually 10,000 TPS. So if you're looking at very, very high throughputs that you need between API Gateway and Kinesis, you'd want to raise that soft limit by submitting a support ticket to AWS and just having the limits raised. And yes, and
sorry, that was maybe a flippant remark on my kind of thing.
And yes, Struth makes a comment about the KPL. Yeah, absolutely. You could use KPL to push out records from on-prem as well. Let's see, what else have we got here? Checkpointing. Yeah, so okay, I'll keep moving on anyway, because a couple of these things I cover in just a few of these slides and just go through. But just very quickly on this, I won't spend too much time on this, but when it comes to scaling your shards, the easiest way to do this is using the update shard count API, and it will do all the work under the covers for you. One of the best practices is to make sure you scale on a multiple of 25%. Typically, that's the fastest way to scale up or scale down. And what happens there is if you run the CLI command and it looks like this, you get an immediate response back because the process is asynchronous. So the JSON you receive back indicates the current shard count, the target shard count, and then this process continues for a while until that's done. So if you're doing that, there's just a few things to bear in mind in terms of limits. These are all in the documentation. I'm just calling them out. But there's a limit to how many times you can update your shard count in a 24-hour period. And there's special limits if you're dealing with very large numbers of shards in the 10,000 range as well. Many of the quotas you see for Kinesis are soft limits as well. The scalability of this service is truly mind-boggling. So we have customers who are running hundreds of thousands of shards. So really, as far as I'm aware, there's no actual hard upper limit on the number of shards you could request. So here's one of the things that is it's an interesting diagram that shows what happens when you split a shard. So what happens here is this is the process of adding more shards because your stream is getting busy. So what happens when this goes on? Well, you have to specify a new hash key value because that's the hash key space and how it's going to be split between the two child shards. Normally you do an even split, but not always. Then after you do this update, the parent shard goes into an updating status, and then it does the scaling. And the Lambda function continues to receive all of the events from the parent shard until those are being exhausted. And then the parent shard goes into a closed status. Then once that happens, it moves on to this point where the Lambda function that was talking to the parent shard now becomes two Lambda functions, and you have one for each child shard. So there are several steps there that are worth knowing about. But essentially what it means is that Lambda doesn't get out of order, and you don't lose any records in the parent shard or anything like that. And then one of the topics, which I know this is a Gillian favorite here, that monitoring Kinesis. So you've got lots of good metrics and alarms to choose from. And some of these are really the absolute minimum. If you monitor these metrics, this goes a very long way for you to keeping an eye on the health of your streaming workload. So iterate at age milliseconds is one of the critical ones I called out here. This is the difference of the age of the last record consumed and the latest record put to the stream. So if that starts to get longer, something is happening. And if you find that that goes beyond about 50% of your stream retention, you need to take action. So if your stream retention is 7 days and you saw this getting larger than that, remember you will lose records once you hit 100% of stream retention. So very, very important metric to be watching and monitoring. And a couple of the others there's a lot of good information in the docs about them, but I just wanted to call them out as things that are worth looking at when you're building these types of solutions. And then, of course, with Lambda, we have the same sorts of metrics as we do in other applications, but also Lambda emits an iterator age metric itself. So that's something else you want to look at when you're building this. This metric indicates how old the last record was in a batch when the processing finished. So if the function's processing new events, you can use the iterator age to estimate the latency between when the record is added and when the function processes it. That's another thing that you want to look at if you're using Lambda to help with processing your stream. And then there's lots of troubleshooting tips around here. I just compiled a few that are interesting around Kinesis. So if your iterator age starts to grow rapidly, there are a few things you want to ask yourself. How many Lambda functions are subscribed to the stream? Can you add another consumer maybe to help process those records? Are you seeing any functions that are showing errors or throttles in their metrics? Are you seeing a large increase in incoming records or incoming bytes that indicate there's a growth on the producer side? And some other things, instead of allowing functions to error out, you could use try-catch handling to log the records that cause the errors and then return successfully. And that allows Lambda to then continue on to the next batch while you investigate the cause of the problem records. And you can also scale the Lambda concurrency by using the parallelization factor as well. By default, that's set to 1, but that can go up to 10. So that's something else to consider if you need to scale up the amount of processing available on the consumer side.
So
and
James,
of course,
the parallelization factor is that my understanding is normally you have a single Lambda function per shard.
Yeah.
Now you can scale up to 10 Lambda functions per shard.
That's right. Yeah.
Yep.
And it's a long name for something that's fairly simple. It really is basically concurrency for a shard. And but before you get there, I'd recommend also just looking at the amount of memory available in your Lambda function, because Lambda memory is also a lever for CPU. And sometimes just increasing the memory available to the function might actually get the performance increase that you need without having to increase the number of parallelized functions running on the shard. So just a couple of very fast things. I know we've only got limited time. Just think about, in terms of troubleshooting this read provision throughput exceeded error. So if you need to remove subscribers, look to see if you've got any unnecessary subscribers. You might have Firehose running, maybe you don't need that, or Kinesis Data Analytics. Those are subscribers too. So you can always turn those off if you don't need them. And if you really do need all of the subscribers and you're reaching these limits, this is when you want to be thinking about using enhanced fan out. So this is a feature that has an additional charge, but fundamentally produces very, very fast throughput for your consumers. So just to talk about enhanced fan out a little bit more. So this scales up the number of functions that can be read in parallel. And it does this by moving from a pull model to a push model. So when you use enhanced fan out, instead of using HTTP, the service uses HTTP2 and pushes records to Lambda. So typically you see a fairly large performance increase by up to about 2/3 when you're using this feature. One other thing just to throw out here, if you've got 5 different Lambda functions on one stream and you turn on enhanced fan out, typically without enhanced fan out, you'd be looking at 200 milliseconds per consumer. And so consecutively, that could be up to a second to process each batch. When you turn on enhanced fan out, these all happen independently of each other and in parallel. So typically in this model, you might find that you could do it in 70 milliseconds instead. So if you have very, very performant workloads where you need very low latency, this is a really good option.
And I suppose that's quicker because it's the push mode rather than polling. So it's literally being pushed into the service, which is always going to be quicker.
Yeah. And then this is what we were chatting about earlier. This is the parallelization factor. And it's exactly what you said, Julian. Essentially, you've got one Lambda function per shard normally, and you can increase that to 10. And so the important thing here is the effect on the ordering, because suddenly you essentially get mini shards involved, and that means that your overall ordering isn't necessarily guaranteed the same way because these shards are working in parallel. So when you turn on the parallelization factor 2, this is what happens. This is a feature that actually works with DynamoDB streams as well. So it's worth remembering that it's not just Kinesis as well.
So yeah, that was the question from the tech guy about 10 Lambda shards. In that case, do Lambdas get duplicates?
Well, it's really it's the Lambda functions in that case are each instance is receiving its own set of records to process.
Yep.
The idea is it's parallelizing the throughput to try and get through the records faster. But it's definitely for something where if you've got no other option for keeping up with the pace of records, it's an easy button to press to suddenly improve the production. All things being equal, switching your Lambda processing or parallelization from 1 to 2 effectively doubles your throughput. So just think about some optimization factors here. And these are some of the things that are easy to overlook. So remember that Kinesis per shard allows 1 megabyte per second or 1,000 megabytes, or 1,000 messages per second. 1,000 megabytes would be great. But in this case, if you have lots of small messages, you might hit the total number of message limit well before you hit the 1 megabyte per second limit. So this is something that you might want to consider fixing. And if you've got a workload where the throughput latency isn't such a factor, you might want to batch those records on the client side so that you're filling the capacity more effectively. And so this aggregation is something you can do to increase the payload size, and it reduces the number of overall messages going through the system. So there's two common libraries that I called out here that are used to do this. You've got the KPL, the Kinesis Producer Library, and also the Kinesis Aggregation Library. And if you're working with Java, on the client side, you can also use the Kinesis Client Library, because that integrates pretty seamlessly with KPL, and that can help with the deaggregation process. Because remember, you've got to deaggregate on the consumer side if you're aggregating on the producer side. So here's a nice little animation showing the fact that when you've got very low numbers of messages, this is what it looks like, that you're getting delivery to Lambda functions with small batches. And so this is something where if latency isn't such a factor, you might want the Lambda functions to wait until there are more messages to process. And so this is something to figure out your batch size optimizations to make sure that you're not overpaying for Lambda with very small numbers of messages. Typically, this would be useful for things like archiving workloads, for example, where the additional latency for waiting isn't really a problem. And so Lambda invokes your records as soon as they arrive. Lambda always wants to do things as fast as possible, but then you also have the choice of creating a batch window. So you can tell an event source to buffer records for up to 5 minutes by configuring this batch window. And really the trade-off here again is latency. So if you want to use batching, that's fine. It results in fewer Lambda invocations, lower cost, but obviously you're waiting for the batches to be full based upon whichever trigger that you've set first to be activated. So do we have any questions? This is a fascinating topic.
No, not particularly, James. We've probably only got a minute of what you want to talk about, and then we probably need to start wrapping up. So what else is in the stream from Mr. Bizik?
The stream of James. I won't go into Kinesis data analytics because it's actually a fairly complicated subject in terms of understanding how streaming SQL works. But right now I'm currently building a new series on the compute blog that's based around streaming data. And so I'm going to go into these topics in a lot more detail. And there's a lot of complexity in the weeds with streaming workloads. So there's lots of topics I'm looking forward to covering when I produce this blog series, because when you actually get into it, it's definitely one of the harder types of application to build.
Excellent, thank you, James. One of the other things, send any last minute questions you got through. We'd appreciate it. One other thing I just did want to mention is actually the Serverless Chats podcast is one of our serverless community heroes. Jeremy Daly, who does that, and there's actually a really good sort of real world Kinesis podcast in number 1 and 2, Anahit Pogasova, who's done streaming at scale using serverless. Now, I know you believe James 100% and AWS is all great, but this is really another perspective on it. And Anahit also had some interesting real world use cases based on the kind of work she was doing with Kinesis. So yeah, definitely worth doing that. Let's have a quick look at the tech guy use cases where I want to RDS and the post to SQS as a single atomic XA type of transaction. If my post fails, I need to roll back from RDS as AWS Friday. The tech guy, have a look at step functions probably. If you're doing anything that is a transaction, anything that needs to have a workflow, step functions is going to be your friend. You can take some of that workflow and transaction automation out of your Lambda function and run it in step functions, which would be a lot better. And thank you, Struth Mate. The record batching and aggregation tip was nice. Great session. Well,
yeah.
Thank you very much for joining us.
And actually, on the question of record aggregation and batching, one other thing to think about is compression, because often people, when they're sending data from the producing device, don't provide it in a compressed format. So one thing you can do is just compress it before you send it and then decompress it on the consumer side. And I've seen workloads where you can reduce the amount of data that's flowing through Kinesis by 60 or 70%. So especially for JSON workloads, they tend to be highly compressible.
Excellent. Well, thank you, James. I really appreciate you spending time for what is a vast topic and managing to get through it so eloquently. Yeah, coming up next week is Serverless Surprise. So Rick Houlihan, who is the master of DynamoDB, is going to be going on. So I'm giving you a tip now. You're going to, when Rick's talking, you probably want to slow down your browser if your video thing can do it at half speed, because he's going to be throwing in information. Eric Johnson is going to be keeping up as fast as he can. But yeah, Rick Houlihan is the master of DynamoDB. Serverless Surprise is going to answer all your questions, which will be super useful from Mr. Houlihan. So this is just the rota that is going on. After that, we've got on the 25th of May, we've got Ben Smith talking about his getting started with serverless, and then the rota goes on. We talk about step functions, back on API Gateway, which I'll be hosting, and then back onto AWS messaging and events. So we're trying to keep this sort of 5-week rota going on, which is going to give everybody a chance to hear about some of our new and cool features, and also to, of course, for your opportunity to ask questions. Sometimes it's going to be developer advocates hosting it, and sometimes we're going to be able to pull in, like last week, some of the product managers who actually build these products. So yeah, we really appreciate you taking the time. Just quickly, serverlessland.com is our super aggregation site for all things serverless. We've got events, we've got learning paths, videos, blogs, all aggregated over here, everything about serverless on AWS. And part of that is the serverless patterns collection. You can see the little button over there. So yeah, look at your serverless patterns. But yeah, if you want to find out generally what's going on with serverless stuff, this is a great website. James, I really appreciate so much you taking the time to talk with us today. I know full well your blog series is going to be amazing. If any of the other 1 or 2 blogs you've written every week or this year is anything to go by, James is our master blog blog basic bot or something. A great job. So thank you very much for joining us here on Serverless Office Hours next week. Happy building serverless applications, and we'll catch up with you next week.
Great. Thanks so much, everyone. Really appreciate it. Have a great day.